You know, that feeling when you set up a new TV and you just push it against the wall, intentionally ignoring the absolute nightmare of tangled cords and power strips trapped back there.
Oh, yeah, we all do it. I
You
mean, it's
learn
the
that.
classic out of sight, out of mind approach to home electronics.
Right, but what happens when can't just hide it? Like, if you're running a massive sports bar or a complex office network, you really can't rely on living room logic. So today we're doing a deep dive into a product page from HDTVSupply for something that, well, solves exactly this. It's the Smart-AVI 8-port HDMI Rackmount Extender.
Yeah, because at a commercial scale, just one loose cable brings down the whole system. You need strict order and ironclad reliability.
And looking at this, well, it's over $1,000, specifically like $1,039. So my immediate thought is, wait, isn't this just a wildly expensive extension cord for HDMI?
I mean, it's super easy to look at the price tag and think that. But consider the logistics of extending 8 separate computer workstations to 8 different screens. Standard HDMI cables, they actually degrade pretty quickly over long distances.
Right, they aren't meant for running across a whole building.
Exactly. And if you try the alternative, buying 8 individual standalone HDMI extenders, you suddenly have 8 separate power adapters fighting for wall space. Plus, they generate a ton of heat.
Oh, right. So you basically just end up building a bigger, hotter rat's nest.
Yeah, precisely. So this device is a rack-mountable solution. It consolidates all 8 inputs and outputs using just one internal power supply. So it replaces all that chaos with a single piece of clean, manageable infrastructure.
Okay, I see the value in that, structurally speaking. But wait, it's not even using HDMI to bridge the gap, right? It's pushing these signals up to 150 feet using standard Cat5e or Cat6 STP internet cables.
Well, specifically STP cables. That stands for shielded twisted pair.
Shielded, meaning like protected from interference, like from other electrical signals nearby.
Spot on. When you're running a wire 150 feet through a commercial wall or, a drop ceiling, it's passing fluorescent lights, heavy power lines, and all sorts of electromagnetic noise.
Oh, sure, that makes sense.
Yeah, so that physical shielding is totally vital to protect the video data.
Okay, but even with shielding, if you force 8 streams of high-def video through internet cables over that kind of distance, shouldn't the quality take a massive hit?
You'd think so, but no.
Because the specs here are boasting about uncompressed video like 1920 by 1200 resolution at a smooth 60 hertz with 0 pixel loss. I'm just having trouble understanding how a basic copper cable pulls off pristine theater quality video without lagging or dropping pixels.
The secret sauce here is a feature called TMDS signal correction.
Okay, TMDS. What does that actually stand for?
Right, it's a bit of a mouthful. It stands for Transition Minimized Differential Signaling.
Wow. Okay, differential signaling. Wait, does that mean it's sending the signal differently to compare it? Like, is it sending 2 versions of the same video data down the wire?
You are right on the money. It
Yep.
takes the original video signal, sends it down one wire, and then simultaneously sends an exact inverted, basically upside-down copy of that signal down another wire inside the same cable.
Oh, I see. So if some random electrical noise like hits the cable along that 150-foot journey, it affects both signals equally. Then at the very end, the receiver just flips the upside-down signal back over.
Exactly. And then it compares the two. The original video data matches up perfectly, but any interference that was picked up along the way is now suddenly inverted against itself.
And mathematically cancels out. Oh, wow, that's like noise-canceling headphones, but for video data.
It really is. It's a brilliant piece of engineering.
So it acts as this like real-time proofreader that instantly fixes typos by comparing the 2 drafts. And since all of this heavy lifting happens right on the hardware itself, I'm guessing that explains why this thing is totally plug and play across Mac, PC, and Linux, like no special software required.
Yeah, completely. It doesn't care at all about your operating system. It only cares about delivering a flawless, uncompressed image by eliminating that noise.
That really changes how you look at commercial spaces. For you listening right now, the next time you're sitting in a venue or an office surrounded by flawlessly synchronized screens, you'll know it's not magic.
Right, and it's definitely not a daisy chain of cheap adapters taped to the floor. It's heavy-duty hardware like this, quietly crunching inverted signals in a hidden back closet somewhere.
Yeah. Though, it does leave you wondering if we still rely on this intense physical infrastructure, like running 150 feet of shielded copper just to guarantee 0 pixel loss, will we ever reach a point where wireless technology can truly handle that kind of raw, uncompressed bandwidth? Like, will it eventually render these intricate physical networks totally obsolete?